Hi, I'm Tiffany Trader, Senior Editor of HPCwire, and we're here at SC15, and I'm here with Addison Snell of Intersect360 Research. We have a lot going on this week. There's so much that we could talk about. We have the top 500 list announcement and the trends that are going on with that list. We have plenary sessions, BOFs, lots and lots of vendor news. So Addison, I was wondering what caught your attention this week?
Thanks, Tiffany. Well, let's start with the top 500 list since you brought that up, and that early in the show always gets a lot of attention. The biggest news on the top 500 list was China all of a sudden having an enormous number of systems. It's more than, or it nearly tripled from 37 to over 100. I think the number was 109 systems based in China, which is higher than it's ever been. And Europe, all the other geographies falling back. Europe is now down to 108, so you have one more system in China than in all of Europe. Now, you can't get too excited and say all of a sudden China bought all of these systems and China suddenly discovered high-performance computing. Really, it's more that China suddenly discovered the top 500 list. China's been very important in high-performance computing all along. It's just now we're putting those systems onto this list and getting a more accurate look at how much of this computational power is in China right now.
Exactly, and we heard at the top 500 analysis session last night that many of these actually were not new systems. You know, this wasn't a big land grab. You know, some of these were 2- and 3-year-old systems that were just benchmarked this year and gave the impression, gave them a much higher ranking on the list. They're now in second place. They have the top vendors. Sugon now is right up there. I believe they're number 3. Behind HP and IBM in terms of system share. And then also United States, fallen to the lowest level since the list was announced. What do you make of that? Do you think is this the new normal, or does the United States have a chance to regain this lost ground?
Well, the first thing to realize with Top 500 is that at some point it's a marketing tool because the vendors help with a lot of the submissions. So Sugon and Inspur and Lenovo will work with their customers in order to get these systems listed on the Top 500, and if they do a lot of it, then that can get up there. It's a interesting look at, but not a perfect proxy for actual system revenue share in the high-performance computing market. If you really want to do analysis of system shares and vendor shares across the HPC industry, you have to do a lot more than just look at the top 500 list. But to your first point about the age of systems, that is something where you are seeing some older systems on this list that it's not turning over quite as quickly. In the top 10 systems, 6 of the top 10 systems are at least 3 years old. And that is unusual for systems to stay at the top of the list that long. That doesn't include the Tianhe system, the Tianhe 2 system, which is still the number 1 system, but it's been slightly less than 3 years. That's another Chinese system. There have been only 3 new systems this year. One of them, the Shaheen 2 system, came out in July. 2 more new systems came onto the list this list in November. Both of them from Cray, one in the United States at Los Alamos, a DOE system, and then one of them at HLRS in Germany.
Right, and we have the Trinity system is the phase 1 of that system, and it's set actually to go all the way to, I believe it's set to go to 42 petaflops peak, if I'm not mistaken there. So there was only these 2 new systems, both Cray's had a very good year on the list. They're up there. But what do you think about this, the diminished list share on the U.S. side?
Well, any other non-Chinese geography, it's just a matter of a zero-sum game. If all of a sudden all of the Chinese systems come on, that means the other geographies are going to fall down proportionally. I wouldn't see that as any kind of signal that the U.S. is losing any kind of position or role in the supercomputing market. That's just a direct artifact of the other systems coming on. The other important trend that's in high performance, that's on the top 500 list, that really is linked to a big trend that we've seen here on the show floor, is an accelerated computing. The number of systems with accelerated elements things like GPUs or Xeon Phis has grown now across 100 for the first time. It was, I think it went from 90 to 109 on the list. So that's growth, and we've seen other proof points in accelerated computing being reported by NVIDIA, being reported by Open Power. You have Intel who's messaging the Xeon Phi processors as you look forward to Knight's Landing. That really does seem to Intersect360 research like we're getting to a tipping point in HPC where we're going to be seeing a lot more with accelerators.
So we're certainly hearing a lot about accelerated computing this year. IBM Open Power is really talking about acceleration moving into the data center. And with the GPUs that you mentioned, with their partnership with NVIDIA and Mellanox, they really have a unified messaging around accelerated computing and getting that compute closer to the data. What do you think about the different strategies? So Intel is kind of having a different messaging around this, right? They have their self-hosted coprocessor coming up, the Knight's Landing chip, the replacement to the Knight's Corner, and this is going to be self-hosted, and they're staying away from the term acceleration for this, because they're trying to show, that this is something that can be very easy, that you can sync up with the Xeon chips, right? And you can use it much more like the way that you're used to using something. Although I understand that the portability, to get that parallelism can be a significant challenge to use this. So I hear that the centers do have some work ahead of them to get their codes ready to use the Knight's Landing chip. But what do you think about Intel's strategy as opposed from the IBM Open Power?
Well, with respect to the use of the term accelerator, it's a valid point that in the end, these are all processing elements of different sorts, and to make the distinction between what's a processor or what's an accelerator, in the long run, you're putting labels on different things. In the current instantiation of the market, the public perception is that these are accelerators. They're attached to a microprocessor at some level. And although I take Intel's point that Knight's Landing can be configured as a native processor, in our current structure of research, we've been grouping it together with the accelerators because that's the way that the market perceives them. I think with Knight's Landing, that might start to change, and we'll talk about these things in a different way. It's absolutely a valid point. But in terms of the code modernization or optimization, that is an area where there is a lot of work that needs to be done. What we're seeing is, in general in the industry, we're swinging back into an era that's more of specialization, away from standardization. When we were talking about the Beowulf cluster revolution, a big selling point of clusters was this notion of portability. I can put my code into MPI once, and it doesn't matter where I get the components from or whose cluster I buy. They all run about the same, and I can just have my code in MPI and port it from one to the next. With all of the different processing options that we have out there now, optimizing my code for Xeon or Xeon Phi or Power or GPU or FPGAs or DSPs or ARMs, there's so many options out there that now you really are seeing I'm going to specialize on one or the other. And if I take one fork in the river, it gets hard to backpedal and take a different fork again. So that's why there's so much emphasis on where are we in the market right now. I do think that accelerated computing is going to be the paradigm moving forward. We had a research report that showed that 34 of the top 50 HPC applications right now are showing some level of GPU support or optimization. And Intel needs to get that ecosystem going around Xeon Phi. That's what's behind some of these community efforts that you're seeing right now.
Yes, absolutely. So in terms of those community efforts, something was announced right before SC, which was an open HPC forum to build a unified software stack. And it was announced with a lot of partners. Some people see this as a play against the IBM Open Power, and I actually understand that IBM is kind of interested in pushing back on that and seeing exactly how open this will be. And I think we'll be hearing more, without saying too much. I think we'll be hearing more about that. But what have you heard with regard to that?
I think Open HPC is probably the most significant announcement for SC15, even though it came out a few days before the show. I think it is in part motivated by open power to say, all right, well, there's also an ecosystem that's around this type of architecture paradigm, and here are all of the partners that can benefit from working together on the stewardship of HPC applications, features, functionality that are going to be designed to work together in this open community. You need to point out that it doesn't include everybody. For the most part, there are only a few vendors that are on the hardware side. There are only a few vendors who are members of both. There are very few vendors who are members of neither, right? For the most part, what you're seeing is that someone's on one or the other. It starts looking like IBM and friends versus Intel and friends, which doesn't mean that these community efforts aren't good. They use slightly different definitions of what exactly is open in each case that, bears examination of what aspects are open and which ones aren't. But, at the top level, you can't be too cynical about it. I mean, the partners who are working together to bring HPC forward, at the end of the day, that's good for the users of that ecosystem.
We're certainly seeing a lot of innovation this year, I think, coming out. And I hear discussion, people are saying that HPC had gotten boring for a while, and now HPC is interesting again. And I think some of that could be traced to the slowdown of Moore's Law. And we're seeing a flattening. If you do want to say that the LinPack is still reflective and relevant, we're seeing a flattening in the terms of the top of that top 500 list. I think Intel would like us to think that the list it swings up and it swings down, and that they have a lot of power coming behind the Knights Landing chip, and maybe we'll see a dam break there. I think that's what they would like us. That's the message they're putting out. So what do you think about the implications of Moore's Law slowdown and that flattening at the top of the list? And also concern possibly that if there is flattening there, we've seen this democratization of HPC, and a lot of that's been driven by what's going on at the top and the activity at the highest element there. And if that flattens, what's going to drive the next set of innovations? So we got Moore's Law, is it flattening, and what's going to drive the next set of innovations?
First of all, I have no concern about the long-term health of this industry. The great thing about high-performance computing or supercomputing is that until one day we wake up and decide that we've reached the end of science and we go, okay, science is done, we figured it all out, we can stop. Right? Science is more or less infinite. These things can be done at an unending level of complexity, and as long as that's true, we're going to need more powerful and more powerful tools in order to reach the new levels of innovation. So supercomputing will continue to go forward. The question is under what model, and you need to remember that we've had this debate before. When we went through the cluster revolution, when Beowulf clusters were new, everyone said, well, that's not really the same kind of scalability. The systems aren't really efficient. There's not the software that's optimized to run on them. Isn't this really the death of the top 500 list because this is completely meaningless? It's the exact same debate we had 15 years ago. And you notice the top 500 list didn't die. Supercomputing kept going forward. We learned to program these things in a new way. Any major architectural shift kind of has these transition points where you have to get used to the new normal of how we're making these innovations. This has the further complication of we're not putting everything onto one common paradigm, so measuring everything with the same yardstick maybe isn't as easy, and you need to put some thought into how you're measuring things for your own application. But Moore's Law, I think maybe you could say the end of Dennard scaling, but these things will keep pushing us into the future. The flattening of the list, these things are temporary. We're going to keep chasing supercomputing into the future to infinity and beyond.
Well, Addison, I think that's all the time we have for today, so I think we're going to have to continue this conversation. Definitely continue this conversation another time. I want to thank you for being here today, and thank you for joining us here at SC15.